Okay, in this video, I wanted to show you quite a few different bits and bobs, all data related. And I'm going to start by talking about bar charts. Now, it might seem to you that the bar charts are super easy, and frankly, they are. But bar charts are still in higher tier GCSE papers. You are expected to know about bar charts. So I'd like to take you through a few key points with bar charts and some of the little twists that you can get. Of course, very basic bar charts are easy peasy, but you can get some strange little twists that I'd like to show you. So to begin with, I've got on the screen the results of an election that happened in Kerala in India. I was very, very lucky in 2008 to actually visit India, and I saw them campaigning at the time, and it was a fantastic experience. The sort of flags and the colours and things were absolutely incredible. People were being very, very passionate about their politics indeed. And then when I came home, I had to look up the results, and this was the results for the area in which I was staying at the time in Kerala. Now, the whole point of drawing a bar chart, or any chart really, is it's supposed to be useful. Now, you don't bother drawing any chart if it doesn't reveal anything important. If it doesn't summarize the data in a useful way, there's no point in doing it. Now, my question to you is, at a glance, can you easily tell who the top three candidates are? Because in this election, the top three candidates won a seat in the local council. This happens in England as well. Very often in council elections, you can put more than one cross on your ballot paper, and say the top two or the top three candidates then represent you on the council. This was very similar. The top three candidates went. Now, can you easily see, just by at a glance, who the top three candidates are? Maybe you can. I find it pretty tricky to do so. So what I'm going to do is I'm going to draw a bar chart. I'll get Excel to do it for me. So I'll say insert a bar chart. And now I think it's instantly clear that these two were in position 1 and 2. So Indian National Congress, that's Gandhi's party. CPI, not sure who they stand for. And then it's not obvious. It's between BJP, who are actually the current government in India, and BSP. So they might be third place. Let's have a little look. So it's between BJP, who got 84,094, and BSP, who got 86,000. Okay, so BSP are actually in third place. It's these three that are in third place. But certainly, first place and second place was suddenly completely obvious from this bar chart. And you might be able to just see these little tiny little bumps down here. These candidates didn't get 0 votes, far from it. In fact, most of them scored in 4 figures, but it's so tiny in comparison to numbers like 0.3 million, like this Indian National Congress candidate got, that you can hardly see it on this scale down there. So you only bother drawing bar charts and things like that if it is in any way useful. And I claim in this particular example that it is indeed useful. It reveals something about the data that's easier to see in bar chart form than it was from the raw numbers. Sticking with the theme of elections, these were 2 European Union elections. I suppose the UK won't be participating in any more elections to the European Parliament, but these were the results for the UK. I think the UK gets, I can't remember, I could add it up. I think the UK before we left got about 70 seats in the UK Parliament. That means we could send about 70 representatives. I'm not going to add it up, but at the time it was this number of representatives. So, for example, in June 1999, the Conservatives won 35, but then 5 years later, they only won 27. So the Conservatives went down a bit, Labour went up a bit in that particular time. Now, what I'm going to do before I draw my bar chart is I'm going to work out what the change is, and I'll ask Excel to do this. We'll do the 2004 votes, take away. Oh, I said that the wrong way around, didn't I? I mean, you can see why now. I actually said that the wrong way around. I read the graphs the wrong way around. Sorry. So from 1999 to 2004, Labour went down, didn't they? They went from 25 down to 19, just like the Conservatives went from 35 down to 27. Right. Anyway, this represents the change from 1999 to 2004. And if I draw a bar chart of this, it looks a little different, but you might be able to predict what's going to happen. this is what my bar chart looks like instead. My x-axis is here where it says 0. And this scale over here is not number of seats, it's the change in the number of seats. So you can see that Labour have lost seats. Labour have lost 6 seats between the 2 years, between June 99 and June 2004. Conservatives have lost 8 seats. But all the other, well, I say all the others, the Lib Dems and UKIP and Green, they gained, but the Nationalists and the others, that doesn't mean over here that they got 0 seats. It just means the change was nothing. They got the same amount of seats in 99 that they got in 2004. So bar charts could look like that. If you want to represent change, you can go above and below the x-axis. This is another example where suppose I do an exciting study into the number of cups of tea which are drunk in the staff room in the morning and in the afternoon. So the way I would read this is on Thursday morning. I don't know why this keeps coming up, by the way. Anyway, never mind. On Thursday morning, we had 40 cups of tea drunk in the staff room, but on Thursday afternoon, it was 35 cups of tea drunk in the staff room. I'm going to represent this in a couple of different ways. Both times will be bar charts. The first time is going to be this. This is going to be one of my bar charts. And the next time I do it, I might need to start again. Yeah, otherwise it would have gone over the top. Insert. This time is this one. Now, I claim that both of these bar charts are useful, but for different reasons. Now, both charts enable me to make comparisons, but they allow me to compare different things. So over on the left, morning and afternoon are next to each other. This is called a multiple bar chart when you do that. If you have more than one sort of, bar for each category, that's called a multiple bar chart. And in this particular case, because there's 2 bars, it can also be called a dual bar chart, D-U-A-L, a dual bar chart. But you know, there could be 3 or 4 bars here, you know, and in which case multiple bar chart is a better description for it. Now, what I'm comparing here very easily is morning and afternoon. I can see that on every single day, the AM, but the blue bar is slightly higher than the PM bar. So blue is slightly higher than red. Therefore, I can immediately tell that more cups of tea are drunk in the morning than in the afternoon for every single day. Okay, in fairness, that's actually quite clear from the table as well. 30 is bigger than 28, 45 is bigger than 43, etc., etc. But if I had a lot more data, it might be quite difficult to compare every single pair of numbers, but from the table, so from the bar chart, I could very quickly see that like the left-hand side bar is always taller than the right-hand side bar. Blue is always taller than red. So that tells me that always more tea in the morning than the afternoon. The right-hand side bar chart, this is the same data, remember, it's exactly the same data, and it allows me to make comparisons. But what I compare this time is a bit different. It's the total amount of tea drunk per day. So over here, I'm not really comparing morning and afternoon, because actually it's very difficult to see whether the red or the blue is bigger. But instead, I'm comparing the days of the week. I can see straight away that on Tuesday, most cups of tea are drunk. So Tuesday is the most common day for drinking tea, more so than Wednesday, but only just, much more popular than on Monday. But so both of these bar charts are allowing me to make comparisons, but over here, it's comparing the days rather than comparing morning with afternoon. The name for the one on the right-hand side is a composite bar chart, composite, C-O-M-P-O-S-I-T-E, composite bar chart. You'll sometimes hear it referred to as a stacked bar chart. So Excel calls it a stacked bar chart, and we tend to refer to it in the UK, though, as a composite bar chart. This is another example of a bar chart, but it's misleading. So, and we're fixing it as well. This represents the average UCAS points. UCAS is what you get when you do your A levels. You might get, and I can't remember the exact tariffs, but suppose you get an A in one of your A level subjects, that might give you, say, 120 points, but a B only gives you 100 points, that kind of thing. I can't remember the exact numbers. I'm sure somebody out there knows. If you've got a friend in the sixth form, you could ask them. I'm sure they know. But that's the idea. Now, most people study 3 A levels, and so this represents the average UCAS points for schools in our local area. Now, people that do A levels at the academy get an average of 298. Apparently, I did actually just make these numbers up for the purposes of this, so sorry. And at Harvey, it's 300, etc., etc. Now, when you put this in a bar chart, you can make it look quite sensational for us, and you know. This is not a million. I did say I made this up. It's not a million miles away from the truth. But there is a big reason why you wouldn't draw the bar chart like this. I wonder if you can see what the problem is. Okay, this is poor design. It's the y-axis over here. It starts at 290, and that's not necessarily a problem, but it's misleading because if you just see the title, average UCAS points, given that the FSG bar is more than twice the height of the academy bar, at a glance you might look at that and think, oh, okay, so on average we do, twice as good as those at the academy, at A level anyway. But that's not true. This bar, yes, it's twice the height of this, but it doesn't represent twice as many points. Far from it. To make this a fairer comparison between the schools, I need to start at 0. So let's start this at 0. And now you can see, actually, it's not an awful lot of difference. FSG is still ahead. We're still the best school in the area, and that is true at A level among all other levels as well. But it's not quite as dramatic as it looked like before. One of the types of question you will have to deal with at GCSE is finding the mistakes people have made when drawing graphs. I suppose that's not strictly speaking a mistake how I had it before, but that graph would be misleading if it was left like that. That's all I want to say about bar charts, but there are 2 other sort of random bits and bobs that I want to do now. These are 2 pie charts. Now, this represents the mode of transport that people use to get to work each morning in these 2 countries. So you'll see that over on the left, we've got this enormous blue wedge, for example, almost half the population over there go by bike. I've got this very thin green wedge over here. In fact, in both of them, the green wedge is quite thin, so bus is not a particularly popular method for traveling to work. Other ways are more popular. But my question to you is, in which country do more people bike to work? Okay, and I'll phrase that really carefully. In which country do more people use their bicycle to travel to work? And the answer is, we can't tell. My question was, I'll say it one more time, in which country do more people travel by bike? And we don't actually know. Luxembourg has a bigger proportion of people. It looks like it's about half. Actually, it's helpfully coming up there. When I hovered over it, it said 49%, didn't it? Is it going to do it? Yeah, there we go. Luxembourg point bicycle, 49%. Is it going to do it if I hover it? Yes, it is, 15%. So it's a bigger proportion over here than it is over here. But you might also see the values. There's only 4 million there. Now, what's it on about? If I drag these out the way, underneath was the original raw data. And it turns out that Luxembourg is not a very big country. When you compare the populations of Luxembourg and Germany, Luxembourg is tiny in comparison to Germany. Germany is massive. And so you look at this, and although Germany only had 15%, and Luxembourg had 49%, it turns out that 15% of Germany's massive population is a bigger number than 49% of Luxembourg's small population. And so it turns out that the answer to my question, which we previously didn't know, but we do now because I'm showing you the data, is that Germany has more cyclists by a lot. by a factor 2.5. There's almost 2.5 times as many cyclists in Germany as there are in Luxembourg. And that's just because one country is big and one country is small. The important point here being that a pie chart is only telling us pie chart's only telling us about proportions. It's not telling us frequencies. So I don't know how many people are represented on the pie chart unless I'm told. I would need extra information given. So it's only useful for comparing proportions or how one category relates to the whole. My last example then, I'm going to draw what's called a time series in a minute. Time series is an important graph that we draw in mathematics. Now, I want you to suppose that I've got this brilliant product and I've gone on Dragon's Den and the dragons are all sitting there and I do my slightly cringeworthy presentation and the music stops and the dragons start asking me questions. Now, I've claimed in my pitch that my sales trebled in about 6 months of trading. And that is almost true, because if you multiply 37 by 3, that's what treble means, times by 3, you get 111. So it's pretty close. It's not exact, but it's not bad. And no one's going to quibble about that tiny difference there. So it looks like my sales have trebled in 6 months. And well, what does that tell me going forward? Probably not a lot when I reveal more information in a minute. Now, I just want to say that you might think I've got the months wrong here. I know that February is the 2nd month and March is the 3rd month and so on, but that's not quite what I'm saying. I only opened my business in February, so after 1 month of trading, or rather in the first month of trading, I sold 37,000 units. And in my second month of trading, I sold 33,000 units. In my third month of trading, I sold 40,000 units, and so on. So that's how you read the graph. So I haven't just messed up my months. It turns out that my third month was April of me being open. So I'm going to draw a graph of this information here, but I'm not going to do it in Excel. I'm going to do it in a slightly more powerful piece of software. I'm going to use Autograph. And this is what it looks like. So my first month's sales figures are up here, and then my second month's sales figures are here. So this the label on this axis here should be units sold in thousands, and down here it's the month number that I was open. I might want to start making forecasts. The dragons are going to ask me, how much do you think you're going to be making this time next year? What are your 5-year forecasts? How much money can I expect to make in 10 years' time? They're the kinds of questions they ask. So I'm going to draw lines of best fit on here and try sort of forecasting what goes on. The most simple line of best fit that you would do is just a straight line. It's already drawn on there. I just need to make it change color so you can see it. So there we go. It's a straight line. I hope you can see that the points are not that close to the line, but it is the line of best fit. It's the right answer for the line of best fit. And I could actually zoom out a little bit. Let's edit these axes a little bit. Let's go up to 24 months, so 2 years later. Let's be ambitious. Let's assume that I might be making a lot of money. This is forecasting that if I carry on with similar sales, and if they're steady in a straight line, then after 2 years, I'll be making sort of 300 and something pounds in that month. It wasn't pounds, was it? It was thousands of units. So I'll be selling 300,000 units in that month there. Possible, but probably not. Let's get rid of that one and try a different line of best fit. Now, I said earlier that I'd trebled in 6 months. The previous line of best fit that I had on there was a sort of additive thing. I add more and more each month. I add the same amount on again each month. Whereas if I'm sort of trebling, that's like multiplying by something every 6 months. And the model for multiply by 3 every 6 months is actually this. This is the model you would use if you're multiplying by 3 every 6 months. And it actually gets much closer to the points. is a much better line of best fit, and it's much more optimistic. It suggests that it's going to keep multiplying, keep multiplying, keep multiplying, and in fact, that's suggesting in the new year, I'll already be selling 480,000 units each month. And this is the kind of wacky thing people do say when they're on Dragon's Den. It's, oh, I'm going to make £4 million in my second year, and the dragons sort of shoot puzzled glances at each other. But this is the kind of things that people are doing. They're fitting curves, they're forecasting in the future, and it doesn't seem super unreasonable until I tell you that what I'm selling is actually ice cream. And if I go back to my original data, we can see what's happening here. Is it really that surprising that I don't sell an awful lot in February, March, April? It's slowly ticking up as we get into the summer. By the time I'm in July, August, I'm selling loads. I'm selling plenty of ice cream in the summer, and just not so much in the colder months. So now that you know I'm selling ice cream, those forecasts are a bit daft. It's much, much more likely that my line of best fit looks something like this. And I'm going to zoom back out again. Let's go axis. Let's take this back to how it was before. It was far too rosy a picture. This is actually the curve that fits the data best. It's very, very, very close to the data indeed. But what this model is predicting is that sales will naturally go up and down, like the tides. They'll go up and down with the seasons. And that one makes far more sense. So it might initially appear that if you had sort of a couple of years worth of sales data, it might look like sales are going up and down all over the place. But actually, it's just a seasonal effect. It's just for something like ice cream, it's very dependent on the season, and we got a good year's weather that year, and so on. So the line of best fit for that should look more like this. When you draw your time series at GCSE, you are expected to put a straight line on there. And the reason for that is you might have both things going on. It's very hard to gesture this on the screen, but I'll try. It's possible that you've got this sort of wavy curve, but it's still growing. So I don't know if you can see what I'm doing there. I've done my best there. In fact, I don't even know if my mouse pointer is coming out on this recording, so I might be wasting my time again. So I'm making the sort of wave pattern, but I'm also increasing as well. And if you draw a straight line of best fit on your time series, and it is sort of this upward kind of slant, then what that's telling you that despite the fact that you have seasons, your sales are getting better and better over time. And if you had a sort of wavy curve that's still waving, but it's sort of getting lower and lower and lower as well, so a straight line ends up going sort of downwards, that's telling you that the trend over time is going down. So you've got the seasonal effect, but you're sort of getting worse and worse over time. You're not selling as much as time goes on. And I think that's everything I want to say about all my bits and bobs. There will be other things that I need you to look at, but I think that's everything I want to say.